So this afternoon, we're going to talk about supporting children with evaluating their inquiry work. So this is where it features in the national curriculum. Again, I've just taken this from the Working Scientifically matrix on the Plan Assessment website. So you can see there that there is no statement about evaluating in Key Stage 1, and then the statements start to appear in Lower Key Stage 2 and Upper Key Stage 2, and we'll come back and look at this in a little bit more detail later. So whilst there's no expectation for children to evaluate, so we wouldn't need to be assessing children's evaluations in Key Stage 1, that doesn't mean they don't actually evaluate. And the way that you would see that they're evaluating is that as they're going through their inquiry work, they may well change their method as they're going through. And it's not just because they've randomly decided to change or they've forgotten what they were doing. When asked, they can actually explain why they've changed their method, why their method that they're currently using is better than the one that they were using prior to that. And that may have been from looking and seeing what other people are doing. And sometimes they may just realise that what they're doing is not actually answering their question, and they may ask if they can start again. So those are indicators that the children are actually considering and evaluating their method as they're going. So what that might actually look like is that, for instance, I'm just going back and using the same example that we talked about last week, where children are thinking about what materials or what object would I use to mop up a spill. And it may be that you give each group of children, a group of 4 children, these resources. So there's 4 objects, 4 materials that they would be testing, and they've got 4 sort of other pieces of equipment, the pipettes, the teaspoons, syringes, and then they've got a bottle of water. And typically what might happen is that each child takes responsibility for the sponge or the J-cloth, etc. And they also then grab one of the other resources. And they may well even take it in turns to test their cloth. But they will tend to use the pipette or the teaspoon, and eventually what may happen is that a child realizes that actually that wasn't fair for my cloth because you used much less water than I did, or that's not fair, you've just cheated, you've used less water. So then they'll actually think, well, actually we need to do this differently, so let's start again, and actually let's all use the same syringe or the same pipette, because then we get the same amount of spill and it will be fair for our cloths. So they actually have this understanding of fairness, and that's what we're looking out for. They may also notice that one of their cloths was much larger, and therefore it stands a better chance of mopping up everything. So they may decide that they need to cut it down and use the same size. So they're already doing that evaluating, but there's no expectation that we would need to assess against that. So then when we move into Lower Key Stage 2, we've got this little part where it says that they suggest improvements, and it's very vague. So we're going to go and look at this in a little bit more detail. I'm trying something different this time. You'll see in a moment, it's all very exciting. So the inquiry that we're thinking about is, how does changing the surface affect how far a ball rolls? And over the weekend, I've had great fun trying this inquiry out, and we've created a little video. Try to not get distracted by my dog Chili, but we had to have her out, otherwise she'd have been barking in the kitchen. So this is test 1. I'd like you just to watch this, and then I will show you test 2, and this is using my first method. So if you could just watch this video quickly. Okay, so that's my first test. And then this is my second test on a different surface. Oh dear. I'd like you to be thinking about the methods I'm using, and in a minute I'm going to ask you to post any suggestions about what I should do differently. Okay, so you've seen method 1, both tests. I'd just like you to type on the chat if there anything that you think I should do differently if I was to do this better, if I was to improve my method. And I think you spotted the error there, that if you didn't spot that, I was just simply holding it up there, and who knows whether I was holding it in the same place or not. It's interesting, what happened there when I was doing that second test was that something unexpected happened, and in this instance my dog just decided to stop the ball, and children will actually repeat tests like that. So actually I sort of went, oh, that's not worth, I'm not going to do that one, I need to do it again. And that's what we want the children to be thinking about in lower key stage 2, where if we get a dodgy result, if there's something that went wrong and we know that that's not the result that we, it's not a true result, then we repeat it again. I would say it's probably good practice to perhaps write the measurement down, but then cross it out later as an anomaly. So let's now look at method 2. So you can see here, it is now propped up on the box. Is there anything else you would like to comment on about this method? Second test. Okay, so Leanne, I'll just let you finish watching. Okay, so just looking at the things you're typing on the chat there, I've now got it starting from on the same height, so that's one thing I've got under control now. Leanne, yes, I did actually, you can see there's a little peg, and I did start the ball from that peg each time, so I did think about starting it from the same place. There is an issue with the ball hitting the side, so that is still something that I've not been able to control properly. And then we have this, is the slope still the same as carpet thickness? Oh, good point. That actually, yes, I've gone from the carpet to the wooden floor, so there could actually be a difference in level. So actually, although I think I've controlled the height of that ramp, maybe I haven't. There probably is a slight difference if the carpet and the wooden floor aren't at exactly the same level. So that's a good thing I hadn't thought about either. And then using the same measure. Does it matter? And this is something that is, and we will come back to this later, but actually, do we think it matters? Type on there, does it matter? I did change, you notice there, I changed from the sort of sewing tape measure to more of a builder's tape measure. Does it matter if I use a different measuring device? Type yes or no. Okay, so there are things to think about, but if we are measuring in standard units, and yes, assuming that our fabric tape measure hasn't stretched and it is still measuring in standard units, then it doesn't matter whether we're using the fabric tape measure or the more builder's tape measure, because we are measuring in standard units. But we do need to make sure that we're using that piece of equipment correctly. So if there is a little bit at the end before it starts 0, I would need to make sure that I'm I'm taking that into account. So thank you. So you can see there that there are a number of things that the children will be picking up on. And the important thing is in lower key stage 2 is that perhaps we're going around whilst they're doing the investigation and asking them questions about why are you doing that? How have you improved your method? Have you refined your method as you're going through? And then get them to reflect on it afterwards. So they're beginning to identify what things they need to keep the same. So we've got that question then, why do you need to keep the height of the ramp the same? That was something that you picked up on very clearly. And that would be a question that I would ask the children, why is it important? And it's the answer that I get from that which will help me determine whether the children have got a good understanding or not. What children will often say, and this is what teachers often say when I'm talking about it, is to make it a fair test. And that's almost because we've had it drummed into us that to make it a fair test, we've got to keep one thing the same, one thing changed, and everything else has got to be the same. And it almost becomes a default go-to phrase that actually, if I just say that, it gets everybody off my back. But actually, that doesn't necessarily show a good understanding. I would actually prefer that the children can actually talk about, well, actually, if you change the height of the ramp and the surface, you don't know which has made a difference. Was it the height of the ramp that made a difference to the distance, or was it the surface that made a difference? And I think it's more that understanding that we need to make sure the children have got, not that they're just parroting a phrase to make it a fair test. So we're going to do another one now. Again, this one is about how does a surface affect how long a spinning top turns. So if you have got a phone handy and you can find the stopwatch on your phone in the next couple of seconds, then that would be really great. If you can't, just count in your head. And what I'm going to do is ask you to post your timings onto the chat when the video clip is finished. It's very short, so get yourselves ready. I'm going to start the video clip now. Okay, post your timings. Okay, so I think what we can see from the results coming in, there's actually quite a wide variety going on there. And some people, I can almost tell, well, I can tell which people are using a stopwatch and which people are counting, because you can see the difference where we've got decimal places and other things like that. What was one of the issues? Did anybody, could you suggest a way that I might make this easier for you? Thank you. We need a countdown. I'm just going to go with that then. So this time, if you could only submit if you have got a stopwatch this time. So if you haven't got a stopwatch, then just resist for the moment. And I'm going to give you a 3, 2, 1, go. Yes, the view was difficult just because of the way we were filming it, but hopefully with a 3, 2, 1, go, you'll be able to see a little bit more clearly now.
Here we go.
3, 2, 1, go. Stop.
Okay, if you could post your times.
Okay, so what you can see from that is that the results have got a lot closer together. By adjusting our method, we've managed to narrow the distance between those results. And again, that's what we would expect the children in lower key stage to be doing, thinking about refining their method. Okay, so let's move on now to upper key stage 2. And we've got this statement from the national curriculum about explanations of and degree of trust in results. And I think to understand that, we need to also look at a different statement in the national curriculum, which talks about how we take measurements and that we should be taking measurements with increasing accuracy and precision. And that is what will help us with our evaluation later. So I want us to think about next, what do these words accuracy and precision mean? So I would like you just to reflect on those two words and go to www.menti.com and pop that code in and just show for me how confident you are to explain what accuracy is, what precision is, and the differences between the two. Okay, so we're sort of 3.5 out of 5. So I think there's scope for a bit more clarity on these things. And then, thinking about explaining the difference, obviously people are feeling a little less confident with that. So that's what I'm going to go on and talk about now. So accuracy is defined as how close a measurement is to its true value. So what is the real answer? So to increase accuracy, we need to control variables. So if you remember the ball on the ramp right at the beginning, we needed to control the height. We also should have been controlling whether it was where we were starting it from the same place. We needed to control whether it was knocking on the sides, that sort of thing. So anything that we thought might make a difference, we should have been controlling. And this is the difference between lower key stage 2 and upper key stage 2. In upper key stage 2, we would be expecting the children to think about these variables in advance and planning to control them. Whereas in lower key stage 2, they'll probably be identifying these variables as they go through and then controlling them as they go. The other thing is taking repeat readings, that I don't know if I just do it once, my dog ate it, that sort of thing. Things go wrong. So we just take repeat readings. And then if there's a result that sort of stands out as being markedly different, then we can then ignore that one. So increasing accuracy, we do by controlling variables the best we can and then taking repeat readings. So having a little look at this next inquiry. So now we've got a car going down a ramp and we're changing the surface of the ramp and seeing how quickly the car travels down the ramp. So I'm just going to play this video. So this first method, you can see we've now got the ramp on a proper ramp stand. You can probably quibble later, which I genuinely hadn't thought about, the fact that it's on 2 different surfaces and there might be a slight difference in the height of the ramp. So that's a possible variable that I haven't controlled. And what we're doing is timing it. So if you've got a pen and paper, you can actually jot down the times as it goes through, and we're going to make quite a lot of repeat readings. So just try and note and keep an eye on those timings that we're getting. Okay, so I have actually written I've recorded those results into a table for you. Let's assume that I was doing my best. The car was starting at the same place each time. I was doing my best to put it in the middle so it wasn't banging off the sides. So I've controlled all the variables that I was able to, and those are the results. And you can see that they're quite evenly distributed. We may then take those results and come up with an average, and the average for those is 0.96. And you can see that they're actually all fairly evenly distributed around that. So we feel fairly confident that we've got the true answer because we controlled all those variables. But there is a discrepancy there. And that's what we're going to think about in just a moment. So this is method 2, and I'll just play this. So now we're using a data logger. This is measuring it in a slightly different way. Underneath the car is a magnet, and as it goes down the ramp, it passes 2 sensor points. So it's measuring the time between point A and point B. So I'm just going to run this video again for you. And you can see the readings there. Okay, so you actually, if you could see there that actually the result was hardly changing at all. We've basically got 0.48 and 0.49. So there is a difference between those two different tests, and that may be for two reasons. Partly because the distance that we were measuring over was slightly different, but also when we're using the stopwatch, that is relying on somebody starting and stopping the stopwatch, and the chances are, due to our reflexes, is that the right word? Reflexes, there will be a slight delay between starting and actually pressing the button or ending it. So there may be a systematic error within that. Whereas here you can see it's taking the readings are all very close together. So, and that's to do with precision. So precision is how close two or more measurements are to each other. So in this second example, the measurements are really close together. So those results are more precise. Whereas in the first example, the measurements are further apart, so they're not so precise. That equipment is actually, it's a data harvest data logger, and they actually sell the ramp and all the bits and pieces with it. I was just lucky I happened to have one lurking in my house, as you do. But if you look on the Data Harvest website, it's a sort of ramp kit, and it comes with all those bits and pieces with it. The number of times a test should be repeated is an interesting one. I would say at least 2, and then as many times as you need to. Because if, for example, I was measuring the weight of something, so if I'm measuring my weight, I will stand on the scales, I will get a reading, I will get off the scales, I probably may just check, I may just get back on again, optimistically hoping that it might have changed, but the chances are it won't. My scales actually do change, you do have to get on them twice. Third time, it doesn't keep going down, it stays in the same place. So for some reason, there is that slight error the first time, but then it settles down. So actually, for me, getting on the scales, I get on the scales twice, knowing that the second one is right. I need to have done it 3 times, or possibly initially do it more times to check. But then actually, if the answer is the same each time, I don't need to keep going. But it's really important that if the results are scattered all over the place, we need to do more repeat readings. So there isn't a number, it depends on the situation. It isn't this thing that we do 3. That's a very common thing. We do 3 and it makes it better. Well, actually, sometimes we may need to do 5, we may need to do 9. We tend to do odd numbers because I think it just makes the average better for some reason. I don't actually know whether it's better to do odd or even numbers, but the important thing is we need to do as many as we need to. Okay, so precision is how close the results are together, and you could see that second measurements using different equipment meant that we were able to be more precise. So let's just have another little look to think about what else we need to consider. So here we've got, you can't see at the bottom there, but the force meter is attached to a piece of wool. And what we're going to be doing is pulling it to see if we can measure what is the force needed to snap that thread. So this is the first go. So maybe again, if you can just look and see what you think the result is for the force needed to snap. Any suggestions? Or have you got a suggestion of how to do this better? Okay, spot on. You can't tell. All you know is that it went beyond the scale. So there was a larger force than that force meter is able to measure. So I need to use a different force meter. And this goes back to that point that we were talking about earlier about choosing the equipment. It's not about using the same measuring equipment, it's about using the right measuring equipment. So in this case, that force meter is just the wrong one to be using, so I need to use the right force meter. So let's try again with a different force meter. Anybody want to suggest what you think that was? Okay, again, we can see there's a little bit of discrepancy coming in. And I think that's because perhaps the method we're using, is there a way that we can refine this method? So what I'm going to do is I'm actually going to play it again. And in an ideal world, we need to pull it really slowly. We need to keep our eye on that measurement. And what you might find useful is actually sort of to count as it goes past. You go 5, 6, 7, 8, 9, 10, and just be counting in your mind as it goes past. So I'm going to play it again and see if you can get a more precise reading this time. Okay, I think it still went a little bit too fast. I'd probably like to slow that video down really, but that's beyond my ICT skills. But I think we are getting a narrower band. From my eye, it certainly snapped before it got to 20. I hadn't said 20 in my mind, and it was sort of, I think it was more between sort of 15 and 17, somewhere near there. So you can see that actually we need the right equipment, and then also we can still think about how we refine our method further. So to increase precision, it's about choosing the right measuring device, and it won't necessarily be the same one for each of the tests or the different ones that we're doing. We do need to make sure it's calibrated, so we would need to make sure that we're not introducing a systematic error. If it doesn't start on 0, it will always be 0.1 or something out. So we need to make sure that we calibrate it or take that into account. It's the same as not forgetting the end of the ruler if 0 isn't on the end of the ruler. And then we can also refine the method. Like pulling more slowly and counting, keeping it eye level, all those things that we know are good practice. So here you can see those are the ways that we improve the precision. So just thinking about those 2 words again. So accuracy is how close the measurements are to the true value. Precision is how close the results are together, but that actually may not be the true value. So they could be very clustered, but actually due to some other error, a systematic error in the way that we're measuring, or because we've changed a variable, we actually may not be close to the true answer. And really what we want is something that is both precise and accurate. That's what we want to be thinking about when we're taking our measurements, and that is what we should be thinking about when we are evaluating. So just as a little sort of analogy to help you with that, that first dartboard, you can see they're all around the center there. And if it's the center that we're aiming for, that is quite high accuracy, but actually low precision, because we're not close to that true answer. But if we were to average it out, we would be in that center part. The second one, the arrows are all very, the darts are very close together, so it's very precise, but you can see they're not clustered around the center there. So it's precise, but not accurate. And what we're aiming for is that third one, where actually they're very close together. So they're very precise and they're centered around that center. So they're precise and accurate. And that's what we're looking for with our results, both precision and accuracy. But the way that we get those things are by thinking about slightly different things. So I just want you to just now reflect on what we've been talking about and go back and think about, do you feel more confident with that accuracy, precision, and the differences between them? That's looking a lot better. I like the fact that actually explaining the differences has clearly gone up now, and it's much more in line with the other 2. So not only do you know what the 2 are, you're actually better able to explain the differences between the 2. So that's really great. So let's just very quickly to summarize. So what does a good evaluation look like? What sort of things should we get the children to think about? What success criteria might they use? We do need the children to think about and talk about the accuracy. So get them to talk about the variables that they did control, but any variables that they identify that they weren't able to control, because sometimes you just can't control all the variables. A discussion around repeat readings. Did they take sufficient repeat readings, or if they had more time, would they benefit from taking more repeat readings? And then also getting them to think about precision. Were they choosing the right resources to take their measurements? And did they think about whether their method was quite right, or should they refine their method a little bit more? And sometimes getting the different groups of children to share their particular methods, they may be able to go, oh, we didn't do that, but actually we could have picked up on that idea that that group over there did. So sharing their methods may help them with doing an evaluation. So I very much focused on evaluating during a fair test because that's where we tend to do a lot of our evaluations, but that doesn't mean we wouldn't evaluate other types of inquiry as well. So when we're researching, we should be getting the children to think about the reliability of the sources they're using, which websites are more trustworthy than others. Do they need to check their answers using more than one source? It's the sort of equivalent of taking repeat readings. So we should also evaluate our research. When we're doing pattern seeking, again, there is that element of controlling variables, although there is often the one thing that we can't control is the difference between the examples that we're using. Thinking about how much data we need to gather. Do we need a bigger sample? And also the range. So if we were looking at, for example, does the size of hands, do people with bigger hands have larger feet? We don't want to just look at 2 people. That's not going to give us enough data. We'd need to look as many people as possible. And we don't want to look at 100 people who've all got size 4 feet. We'd want to increase the range of that. When we're doing observations over time, again, we need to think about the frequency of measurements. If I'm thinking about the size of an ice cube as it melts, there's no point taking a measurement after half an hour because actually there's no ice cube left. So we need to think about the frequency of the measurements, and then also how long to continue. Have I seen enough, or do I need to keep going for a little bit longer? And then with classification, we just need to make sure that we're not looking at too stereotypical examples and possibly broadening the examples that we use. So again, if any of you have got access to examples of evaluations that the children have done, it would be really lovely. We did get some things sent to us last week about predictions. So please do have a little look. You may not be able to access your books now, but maybe when you do go into school, if you are able to have a little look through and send any examples that you've got, both the good and the bad, so from different children, because then we can start looking at what would we do to support this child that's not yet got it. So if you do have anything, please do email it to us. You mentioned discussing, is written evaluation necessary? I would always say no. You need to be confident that the children can do it. It might be that they talk through an evaluation together. It may be that they do a group evaluation. It may be that you're just listening to those discussions. But there may be children that will be able to write it down, and that's absolutely fine. That's an assessment issue. The important thing is children are evaluating. The second issue is how do you assess it? Sometimes a written evaluation will help you with that. For some children, you will need to directly talk to them or listen to the group discussions. The more you do it, the better able you are to actually do that assessment. Thank you very much for joining us. We'll leave the chat open for a little while. So thank you very much. Goodbye.